This tutorial is going to cover primitive type int and its wrapper class. So what I want to do first is show you guys the various ways that we can create a variable in Java. So what we need first is the type of the variable. So we'll say int, and then we'll give it the variable name called var, right? And then we can give it the value. Let's give the value 15. Or what we can do is we can create a variable. Let's say we want to keep a variable for a counter, right? We can say counter. All right, and then we need one for a loop, so we can, or a flag, we can say flag. Okay, and this time we're gonna say flag is equal to 0. I want to give it the value 0. So what happens is that you can have a type here, just like this, and when you have this little comma here, it's saying that, well, we want to create another variable of type int, because the int is the type following both variable names here. So this one right here by default is never used. We've never initialized it with any values. So if we went ahead and did something like SRT counter and we run it, you see that it says that counter has never was never initialized. Okay, so we get an error here. So what we can do is that we can also initialize this to 0 as well, and we will not get any problem. So now when we go ahead and run it, counter would have been 0. All right. So this is one way we can create it, where we don't give it a value until we know what the value is, or we just create it and give it a value. Like I said, what we can do is we can do something like this: int no value. Okay, so no there, and then when we know what we want to put inside of it, we say, well, no there is gonna equal there. Okay, so now we're giving it a value of there, which is 15. We're putting 15 inside of no there. So now when we go ahead here and print out no there, we'll get 15. Okay, so we should get our 0, and then now we get 15. So now that we've seen how to create int variables, let's go ahead and look at the minimum and maximum values that we can store inside of an int. Okay, so I'm going to go ahead here and just clear this out for a second. And what we need to do is we say SRT here, and then for the max variable, what we do is we use integer. We always use the wrapper class, and then max value, right? And for the min value, we do SRT integer dot min value. And then if you want to know how big it is in bytes, we say integer dot byte. Okay, so let's go ahead now and print this out. Alright, so you can see that the max value is about 2 billion, and the minimum value is about -2 billion, and the byte size is 4, because well, it's byte, not bit. Alright, so it's 32 bits to store this, and bytes are a representation of 8-bit, right? So that would make sense that you get 4. So typically with this, right, we know what type of values we can store inside of it instead of an integer. So we can't store any values that are bigger than this. So how do we know if a value is bigger or smaller, right? So what we can do is that we could literally do something like this. So let's go ahead here and create a variable int, and we're going to call this some number. All right, and we're going to give this number, something like this. Okay, so right now we don't know if it really fits or not. Well, by now it doesn't fit, so let's go ahead and use that. Okay, so what we can do is that we can say something like SRT here, and then we can say that we want to see if integer, and they want to use something to compare, right? So we can use compare here, and we want to compare to see if this is less than or equal. All right, so we can say some number, right? And we need another number to pass in. So what we can do is we can actually use our integer dot max values to see if that is less than the max value. If it is, then we can store that inside of this, right? So what we can do is we can say if it's less than or equal to 0, so that means that this number is less than or equal to the max number. You know, I was going to show you guys this, but the IDE already kind of, you know, give us a clue by underlining it. It automatically checks for us to see if that's a big number or not. So we can go ahead and run this. Obviously, this is going to go ahead and return true because that number will fit. But if we have something that was a little bigger, you see, just give us an error. And so let's go ahead and try that. And you see that it says right here that the number is too large for type int. All right. So what we can do is that we can't store this in int, but if we went ahead and changed this to a long, then this number will fit just fine. Okay, so we're gonna go ahead here and add in an L together with take away that error, because for some reason it does that. And now you see that we have a wrong argument here, because this argument needs an int, right? But we're actually looking at a long, so it will not work. All right, so this part will not work. So you can always look at IDEs with if it's underlined in red like this, it means that there's some error within your code. There's something that's not quite fitting right, and then you have to go ahead and change it. Okay. So what I'm gonna do here is, like always, just go ahead and do S out T, and I'm just gonna print a line here, so we can just keep this min and max values and run that here. Okay, that looks clean enough. Alright, so now what we want to do is that we have an integer, right? So we have an integer. I'm going to call this 16. And this is literally going to equal 16. So we have 16 here, and we want to get the binary representation of 16, which is going to be the ones and zeros, right? That represent 16. So what we can do is we can say something like S out T, and then we use integer dot to binary string, right? And then we pass in 16. And what this is gonna do is gonna return the binary representation of 16. All right. So you guys can see that we have 2 to the 0, 2 to the 1. But since this is all off bits, eventually we just get the leftmost bit here, right? So which is gonna be 2 to the 4, all right, which will give us 16. So now what we need to do is let's go ahead and figure out what's the most active bit, or let's figure out how many active bits are here, all right? So what we can do is we can say S out T here, and then we can do something like integer dot bit count. All right, so let's get the active bits. So the bit count is the ones that are on, so it would be the ones that represent 1, and let's pass in 16. All right, so we get 1 because 1 is the only active bit count. So let's go ahead here and change this to something like 15, because with 15 it's an odd number, so eventually we will get 1 in some other numbers to get 15, right? So let's go ahead here and actually run this. And you guys can see that for 15 we get all ones, and the active bits are actually 4, right? Because we have 4. We need 1, 2, 4, and 8 to get 15. So 15, 8 plus 4 is 12. 12 plus 2 is 14, and 14 plus 1 is 15. So that's why we get all ones here. Okay. So now that we've seen this, we know that if we want to use wrapper classes here, we can use wrapper classes and some of your static methods, or we can actually use wrapper classes with objects, right? So object, we can have an instance of an integer class, wrapper class here as an object. So let's go ahead and actually create that. So what we do is we use the type, so which is integer, and then we give it a value, we give it a name. So I'm going to call this integer, okay? And this is going to equal some value. Let's give it the value 23. All right. So now we have this here, and let's say that we want to get a short variable. So let's go ahead here and put short, and let's do this to be short. You know what? I'm bad. You can't use short. Let's just be s here, and let's do it integer, right? To let's see if we can do a short value. So we have one here that will convert an int to a short value. So let's go ahead here and use that. So now we just converted an int to a short, because we can't just go ahead and do this. We can just go ahead and just do integer here, okay, it will give us an error. So what we need to do, we need to take an int and convert it into a short. All right. Sometimes you might try this. Okay, we might do this in other videos where we do a cast right here and here. All right. But the thing is that it says that we cannot cast the type. We can cast the type short. We can cast the type short to this part right here, and we can't really do that. Sometimes it might also do it with primitive types, but with wrapper classes. So let's go ahead here and create an int. Now we had an int already up top here called 16, right? So let's go ahead here and use 16, and let's put this to small value. Okay, so this works, right, with the actual primitive type, but with the wrapper class it will not work. So if we wanted to convert the wrapper class 23, we would need to actually go ahead and use the method that's actually been given to us to convert. So what we do is we'll go ahead and say integer dot short value. All right, and we can do the same thing with long L, or we can say integer, convert this to long value, and then we do long value. All right, or we can do the same thing with you know, a float or something like that. But typically this is how you would use a wrapper class object to collect the value that's in there, convert it to another type so that it will work, right? So now when we go ahead here, we can just do SRT here, and then we can do L, we can print out the value in L, and I'm just going to concatenate here. So by adding a plus here, string, and then passing in S. All right, so we're going to print L and then S, which should both give us the value 23 because we use the same value inside of integer here. And I'm going to go ahead here and just run this. So we get 23 and 23. So you see the way that this actually printed in the same line is because I said print 23 and then put a space in between, and then print 20, and then print another 23, or print L and then put space and then print S, the value in these variables. And then what it did was after that it added a new line right after that. All right, so now that we've seen how to use a few of these things here, I think that most people would like to know how I got these methods here. All right, so what I typically do with most tutorials is I will tell people that it's always important to look at documentation. I get it, it might be tedious to look at, you might not be used to it, but it's something that is very necessary. If you know how to look up documentation, typically it speeds up your learning process. Okay, it will give you the core understanding about that language itself, because those people that created the language are the ones that are actually writing documentations for it. So it's like saying, well, an expert wrote a language and they created documentation for it. Their understanding of the language itself is very integral to how you understand it yourself, right? So looking up documentation is it's a must for me. So here what I did was I actually pulled up the documentation for the integer class here, as you guys can see. And what it does is it gives you all of this, first of all, it gives you all the static fields where you can find out how many bytes, the max value, the min value, the size in 2's complement here, and then the type that it returns, which is int, right? And then you look at here with the constructors, they're deprecated. So you can either still use this, but eventually these are going to get taken out of the language because it's no longer used. And then now you have this here where you can get your methods that are attached to your integer wrapper class here. So what we need to keep track of is the return types here. So this one is the static ints, and this one is just a byte. Okay, so this one, it tells you which ones belong to the class and which ones belong to objects. All right. So for me to use bit count here, I can use a primitive. I can't use a wrapper class instance to use bit count here. I have to use the wrapper class or the type itself to use bit count. So what am I talking about when I mean by the type versus the object? All right. So here Okay, so here we have an instance of type integer. Okay, so this right here is an object, all right, and this right here is a type. Okay, so static fields belong to the type, which are the class itself, and objects or some methods belong to the object itself. So here I can go ahead and use bit count with this. So if I went ahead and I did something like this, SRT, and I said integer dot, and let me try using bit count for a second here. Okay, you would see that even if I pass in the value, this value right here, it's gonna give me an error saying that, well, this is static and I'm accessing via an instance reference. All right, so let's go ahead here and actually run this, and you will see that it actually works. All right, but this is not the right way to use it. All right, don't use it this way. It will give you problems in the future. All right, and besides, if you're programming for some company and just using things like this, right, that are not written in the right way, you might not have a job for a long time. So what you need to do is you need to change this to an actual wrapper class instance. So you see that this is being used the right way because that works. But this is the actual instance, and this is the static method, all right? And this doesn't give us any errors here. So what you want to do is you don't want to use you don't want to use instance variables or objects of any type when they actually belong to the type itself. Because what happens is that static methods typically return static fields, and so you might have something like a player's health, and you're attaching that to an object, and that might not be good for the entire objects that belong to that class itself, right? So you might have different values for something that you want to keep track of under one value. All right, guys, this will be it for this tutorial. I hope you enjoyed it. If you have any questions, please let me know in the comment section below. Have a good day.